Okay, we'll just get started within 1 or 2 minutes. Please ask all your friends to join as quick as possible. Hope not everybody has joined so far. So ask them that the session is about to start. Ask everybody to join, please. And I hope the morning session was useful. I think we could better go in the same way. If you want me to reduce the pace, okay, we'll reduce the pace, speed of the class. But I hope the topics and the contents, whatever we were learning, would be useful for you people. Students will just get started. Ask your friends to join as quick as possible, please. We'll just get started. Good afternoon, students. Good afternoon, everybody. Good afternoon. Can you just tell me, like in the morning session, what were all the topics that we were covering? Can I have some, like what you do is you make a list of what are the things that we have learned so far. Let us have a quick overview. Let us have a quick overview of all the topics that we learned in the morning, and then we'll quickly refresh it, and then we'll just continue with further topics that we wanted to learn. I think I didn't show you by taking a code and putting it in a compiler, and I didn't show you how this activation area is created, everything, right? We'll see that visually now in the compiler. I'll show you. Okay. Yes. Okay, I'm able to see a lot of things like recursion, M color, types of problem, backtracking, types of recursion, time complexity, activation record, stack memory, big O, omega, theta, M coloring, recursion, RAM, ROM, activation area, time complexity, M coloring, backtracking, asymptotic notations. Okay. Okay. So first thing what I will do is, let me just take you to the code editor. The same example problem, whatever we took, right? We'll take it to the code editor. I will show you manually, like how that, activation area creation, everything is happening over there. Okay, let us also look into that so that you might get a clear cut idea of that. So let me first of all share my screen. For that, let us copy the code, whatever we have sample code that we took, right? So let us just copy the same function. Let me copy all these things and let me take it here. Okay, so let me share you the code data. I've just taken it and I've copied it. So I think hope you will be able to see the code editor now. Oh, okay. Okay, I think now the code editor would be visible and the same code, sample code, whatever we have taken there, right? So the same code is available here. So what I will just do is let me create a breakpoint at 11th line, which is main function, where we will start the function. So let me just click on debug and build and debug active file. So yes, starting the debugging process. So keep an eye on it. On the left side, I think you're able to see something called as call stack, right? And this call stack is what the stack memory that I have shown you. And inside this, if you, I think you are able to see that there is main like this, right? This is the activation area. So main is activation area, and inside that main function, now presently we are at 13th line. We are presently standing. We still have not executed 13th line. And when you just come to this variable section, inside that particular activation record, what are all the data available in the locals and also in the register, what is the variable available? Everything is, like clearly it is provided here. Okay, it is just clearly provided here. Fine. Now coming here. So now what I will be doing is I'll be, executing this 13th line. So now presently we are at main function 13th line. If I just execute that 13th line, now you just look at the variable here. After 13th line is executed, variable A is now taking the value 3. Now in 14th line, what we have in 14th line, we have a function call. So once I enter into the function call, can you able to see here in the call stack, initially main activation area. Now can you see this green color line, which means main activation area was stopped at line number 14. After stopping it in line number 14, we have entered a topmost. There is a one more activation area which was created on top of it. And can you able to see that activation area is having variable n, main activation area is having variable 3. So on top of that, we enter into that activation area. Presently, we are standing at line number 4. Now let me execute that, checking whether n is greater than 0. I think the present n value 3 is greater than 0. Condition is true, I will enter inside. And now I'm coming to 6th line. You can able to see here, 6th line present activation area. So what is that we will be doing? We'll be printing the present n value. What is the present n value? It is 3. Present activation area n value is 3. So executing that, we will be printing 3. Next to what we have a function called 7th line. So once I get into this function call, can you able to see the activation area getting created? Initially main, then again fancy. When I come to line number 7, I stopped at line number. I can click on it and check. See there. At that particular activation area, I stopped at line number 7. Now I have created new activation area. I have entered. There I'm just starting with line number 4. So coming to this line number 4, I'm just checking whether my present n value is greater than 0. Okay, my present n value is greater than 0. Yes, it is greater than 0. Okay, yes, it is greater than 0. So if it is n greater than 0, I need to just simply, enter into the function, right? What is the present n value? N is equal to 2. 2 is definitely greater than 0. So condition is true. I enter inside. Coming to 6th line. What is 6th line is having? Printing the present value of n. What is the present value of n? 2. So already 3 was printed. Now 2 is printed. After executing 6th line, I go to 7th line. Now 7th line, I have a function call. So I enter into function call. So a new activation area was created. You can able to see it here. See, initially main activation. On top of it, fancy activation area with n equal to 3. Next, on top of it, again, another fancy activation area, but with n value 2. Now we are creating a fancy activation area with n value is equal to 1. Now coming here, 4th line, if n is greater than 0, I think 1 greater than 0, condition is true, we enter inside. 6th line, printing the present value of n, which is 1. So we print 1. Then after 6th line is over, we enter into 7th line. Is a function call. Again, we enter into it. One more activation area. See, main activation area with A3, fancy activation area with N3, then fancy activation area with N2, then fancy activation area with N1, and now fancy activation area with n equal to 0. So what is the condition? 4th line condition? We'll be checking whether the present n value is greater than 0. I think the present n value is not definitely greater than 0. So condition is false. So once condition is false, we will come out of if block, right? Yes. So after coming out of if block, we are not entering inside. After coming out of if block, we see the closed curly braces of this particular function. So when this closed curly braces is executed, what should happen? Just have a look at here. What should be happening over here? This present activation area that we are standing presently at 10th line, right? That will be deleted and you enter into the next immediate activation area and you will start continuing from 8th line. You're stopping at line 7th line over there. In that activation area, you are stopping at line number 7. Now you'll continue from line number 8 and you will proceed. Let me go there. If I execute this particular close curly braces, you can see that totally now how many activation area is there? 1, 2, 3, 4, 5 activation area is there on the left side. Now one of the activation area will be deleted. You can just notice that. Yes, can you able to see one activation area deleted? I entered into the next activation area. As I said, I was stopping there at line number 7. Now I am just continuing from line number 8. What is line number 8? Printing the present value of n, which is equal to 1. So we print 1. And once 8th line is over, we will come out of if block and we see the close curly braces of that particular function. Once that is executed, what will happen? We will delete this present activation area. We will enter into the next activation area and we will continue from 8th line. So now when we execute this, automatically one activation area deleted, you can able to observe left side, and the next activation area we are continuing from line number 8. What is line number 8? Printing the present value of n. What it is? 2. So we just simply print 2. And after executing 8th line, we will go to 10th line. Okay. So if this 10th line is executed, okay, if this 10th line is executed, automatically the present activation area will be deleted and we will enter into the next activation path. So next activation area, we will start with the 8th line. So we're executing this present activation area deleted. We entered into the next activation area, continuing from line number 8. What is there in 8? Printing the present value of n, which is 3. So we will just simply print 3. And after this line is executed, we will come out of if block. Func close curly braces. Once I execute this, the present activation area will be deleted and I'll be moving to main function. Already 14th line means now I will continue from 15th line. So if this line is executed, I'll go to the next main activation area, 15th line. In 15th line, what I have? Close curly braces. When that is executed, automatically what happens? The entire execution process just simply stops. And what was the final output that will be printed? So now I'll just simply go to terminal and let me execute gcc-o hello and let me go with recursion.c, execute hello, and it is printing 3 to 1, 1 to 3, whatever we did. But can you able to see inside the compiler itself how that activation area is creating, deleting all the whatever I have said manually? I am just showing that inside the compiler itself. Is it now? I think you have to, like now you should have a great grip on this. Okay. I will also, like later on, I'll tell you how to set up this Visual Studio Code also with you. If already, like you people have set it up, no issues. But if not, if you set it, like if you are setting it, just 1 minute. People say that there is a loud noise is there. Just give me 1 minute. I don't use any headset actually. So is there any noise still is there? Is it now clear or is it still voices coming? Occasionally you're getting, is it clear now? Yeah, I think hope it will be clear. Okay, occasionally, I think my mobile phone is near, I think. So I think that might have created something. Okay, great. So, okay, I think my phone was near my laptop. I think that could have created it. Okay, fine. I can understand. I think that notification sound, I think it was nearby. I think the notification could, sometimes it could have created some noise. Okay, fine. So now I think everybody is able to, able to understand it now clearly? How, like even the compiler itself, I'm just showing you inside the compiler, how it is working everything. Is it now clear for everybody? Yes. See, is it, like the theme of the compiler is okay, or let me better go with the dark theme if you require. Is it now okay? Is that is clear now? Is this visible now? Comparative comparing to the white one, is this also okay, clear now? Let it be white or black color. Which one, like which is better actually? Few people. Okay, fine. I think if I go, like 60 people saying black and 40 people will be telling white. Okay, let us not create it as a big issue. So let us, like proceed further. I think let me zoom it a little. Like let me zoom it also. I think now it would be better. Clear view you will be getting. Okay, fine. So now, okay, if it's okay, then fine. Okay, students. So I think we'll just go with this. And the next stuff is, I know like few people said that the cursor is not, like visible. I think for cursor visibility only, I just changed it to black. Okay, fine. So, like what we will do is for further, I think we have done with, okay, we understood what is head recursion. We also have a, like a understanding of what is tailed recursion is. And now the thing is, we need to also understand what is. Okay, so I think now the next thing that we should be understanding is actually tree recursion. I think already we are okay with head recursion and tail recursion. The next thing that we should be discussing about is going to be tree recursion. Okay, let us just discuss a few things about tree recursion. So let me share you white screen for a moment. Okay, so now coming here, the next thing that I just wanted to discuss over here is about tree recursion. Okay, so it's going to be completely tree recursion. So coming to tree recursion, so can you just somebody tell me, like what would be, like tree recursion is all about? Do you have any idea of what kind of recursion can be called as tree recursion? See, tree recursion is, see, actually, you don't. I think here you don't want whatever I was doing. There was no breakpoint was required. Actually, breakpoint is for, like after this, no execution. Let us not happen. Debugging process only up to this certain line only execution will have to be happening. So like that, I can set an ending point, breakpoint. After this, let the debugging process just stop. So for that only, like we do this. Use that breaking. I'll come to that. I'll just also teach you people how to set up Visual Studio Code for debugging purpose. I'll take a separate time and I'll just show you how to set up that. So now coming to tree recursion, if you just have a look at like tree recursion, generally tree recursion is if a certain function, if you take, if we find more than one recursive call, if we find more than one recursive call, then we call it as tree recursion. Okay, if we find more than, okay, if we find more than one recursive call, okay, if we find more than one recursive call, then we call it as tree recursion. See, one best example that we could take is, already we know that, but one better example that I would suggest is, actually we can go with finding nth Fibonacci number. Okay, finding nth Fibonacci number. So what is the recursive approach of finding nth Fibonacci number of a given line? So I'll just tell you what is the efficient approach of this. Okay, so it's going to be hash include stdio.h, and the next one is going to be integer main function. So inside the integer main function, let us take a integer n value. For example, let me take it to be 6, and then let me call this function fib of fib of n. I will call. Okay, so now this fib of n I will be calling, and I will be receiving the answer in a variable ans, and I'll be storing it. And next line I will be printing the variable ans also. So I will just simply print, okay, printf %d comma ans, okay, close parenthesis semicolon. And after this int main is coming, we have to go with void func is the name of the function. Okay, void func is the name of the function, and the first thing is, let me create a variable, take a variable n as a, I think I'll just take in not in integer as a return type, and inside this func I will be taking, if n is less than or equal to 1, if n is less than or equal to 1, I will just simply go with return 1, so return n. If not, else I'll just simply go with the return fib of n minus 1 plus fib of n minus 2. Okay, then semicolon. So if n less than or equal to 1, I will just return n, else I will just simply return fib of n minus 1 plus fib of n minus 2. So then comes main function, then integer n is equal to 6, then integer ans is equal to fib of n, and then printf or %d comma ans I'm just going with. Okay, so this is the usual way of finding nth Fibonacci number. You could have known this implementation. Am I right? Do everybody is okay with this one? Okay, it is fib. I have taken it to be func. So this is not func, this is fib. Okay, fine. So hope everybody know this procedure of finding nth Fibonacci number. Am I right? Hope everybody have already seen this. Yes. So now, when you just look at this, this comes under tree recursion definitely, because more than one recursive call is there. So I think you can have a look at here. There is more than one recursive call is there. Fib of n-1 and fib of n-2 is there. So what I would tell you is that I can just simply rewrite this in a different way. I'll just tell you. In the else part, what I will just simply do is, inside the else part, let me just take two variables. Integer a is equal to, let me do fib of n-1, and let me take the fib of n-1 answer and store it in integer variable a. Then let me take another integer variable b and let me find fib of n-2, and let me store the answer of that in variable b. Okay, then let me close this. And finally, what I will do is, after that a and b is found, right, which is fib of n-1 and fib of n-2 is found, right, then I will just finally going with return a plus b. I will just go with return a plus b. So after else part, I will just close this curly braces as well. So if n is less than or equal to 1, we will return n, and else I will just find fib of n-1 value, place it in a, and then fib of n-2 value I will find and I'll place it in b, and then I will just simply return that a and b, a plus b I will just simply return, and that is, see, same line, instead of giving return fib of n-1 plus fib of n-2, I have taken both the things, and I have whatever value it will be generating, I'm taking it, I'm storing it in a two separate variable, and then I'm just returning a plus b for better execution. While executing, while tracing, we will have a better, like picture. So that's the reason why I'm just doing this. So when keeping that in mind, we need to also take line number 1, line number 2, those things, right? So this will be line number 1, and here it is going to be line number 2. This is line number 3, and let me take this to be line number 4. And then coming here inside main function, we have line number 1. Here in main function, we have line number 2, and then in here it is going to be line number 3. Now, tree recursion, we can also represent it as a tree structure, but also we could do it in, like the general procedure. In the background, it is definitely executed in the stack format, right? So I think we already know the rules and regulations of what, like how activation area creation, everything have to happen. So let me take a activation area stuff. Okay, let me take a activation area. And inside this this is, like just simply stack memory. Okay, this is stack memory. And first thing, very well, the process starts usually from main function. So let me create activation area first of all. And here in this activation area, let me create activation area, like for main function. So for main function, let me create activation area. And this activation area, first of all, we will just simply start with line number 1. So what is line number 1? Taking a memory block, and the variable name is n, and the value that I will be storing inside is going to be equal to 6. Okay, 6. So I think better we, instead of 6, let us go with 4, because it's a very big number. A lot of, like activation area will be created. So better we will go with 4 itself. That is a very minimum value, and we could also finish it easily. Okay, so let me take n value is equal to 4. Now what happens? First line executed. Now what is second line? Second line, listen carefully. We are just calling a function f fib of n, and whatever value that we will be obtaining, that we will receive and we will store it in ans. So but fib of n is a function call. Since it's a function call, definitely one more activation area will be created on top of it. And this activation area is actually for fib. And what is the parameter?